This is Project 2 video number 1 in which we do the pencil and paper part of the project. Let's see, we got a car, a start line, here's my positive x direction. This is x is equal to 0, and the car itself has a velocity at time 0 that I'll call v0. It's known, and it's got a known acceleration. Positive if it's in the plus x direction, same thing with v0. These two have to have opposite signs, and they're to be considered known. They're values that are supplied by the user. And we're supposed to make a graph from time 0, the instant when the car is got its nose right at the start line, and we're actually plotting the position of the front bumper of the car, until the car comes to rest. So we got to find out when the car comes to rest. Find t sub s, s for stop, time when car comes to rest. So from v is equal to v0 plus at, the car comes to rest at, we call it ts. Vs is just 0. That is, when it comes to rest, the velocity is 0. So we just have to solve this expression for t sub s. I'll go at is equal to minus v0. T is equal to minus v0 over a. It was stipulated that these two have to have opposite signs of each other. In other words, if the car is moving forward, the acceleration's got to be backward, and if the car is moving backward, the acceleration's got to be forward, and hence this is always going to turn out to be a positive time. One of these is negative and the other is not, so the negative of the value of one of these givens cancels out that negative, so we get a positive time. So, and I was supposed to be calling that t sub s. So my stopping time is that, and then I have to make a graph of position versus time. Position from our constant velocity equations is x0 plus v0t plus 1/2 at squared, where the initial position is given as 0. So this, I guess I'll go ahead and write it without anything crossed out in it. X equals v0t plus 1/2 at squared gives x as a function of time. So I think I've solved it algebraically. Now I got to write a code outline. I'll go 1, take the arguments, take v0 and a. To use, I'll call this equation 1. Calculate TS, the time when v equals 0. create an array of time values. Let's say times equal linspace from time 0 up to time t sub s, and let's try 100 values of them. Here's the thing with the number of values. You need enough to make the graph look smooth, but you don't want so many that it takes the function forever to calculate it. So that'll actually be a trial value if the function is, the graph is actually going to be a bunch of straight line segments that join together end to end. If that's what it looks like, I can see the corners where one line segment joins another, then I need more of them. If I make them short enough, it's going to just look like a smooth curve. So I'll try 100, and if it doesn't look smooth with 100, then I'll bump it up. I'll use some more. 100 doesn't take all that long to calculate, so I don't have to keep on trying to get smaller and smaller values until it just looks smooth. So I'm not gunning for the smallest value possible, but something that's reasonable and really makes it look smooth. So those would be the times, and then I use call this one equation 2. Use equation 2 to calculate the positions. I'll call it x vals. You should make up your own name for these things. To calculate the x vals, the x values, position values, just about anything. You want to keep it as short, reasonably short, but make it so that it says what it is. So x value says that it's the x position values. And then, so when you do this, this creates an array of 100 time values from 0 up to t stop, which you calculated. And then when you use this to calculate the x values with times as your argument, so it'll be, I'll go ahead and see if I can, v0 times times. It didn't work out too well for me. v0 times plus 1/2 of a times, well, that's times there too, plus 1/2 times a, and then times to the 2. And then plot. Now when I want to plot y versus x, I have to say plot x comma y. I want to plot the position versus the time, so the times have to come first, comma, and then the x vals. This will create a graph of x versus t. And then I have to, you don't have to put this in the code outline, it's just an outline. But after you do that, you have to title the graph and the axes. In other words, make it look right. But I think this represents the rough outline of the code. V0 and A are given. And yeah, I'm not actually going to be able to call my variable v sub 0 because I can't put subscripts in there, but that's okay. I don't have to give all the details in the code outline, just a rough idea of what I'm going to do. So I think we've got it covered. That should generate the desired graph. Let's call that a wrap for project 2, video number 1.